Hey everybody, I'm Haven King. I am an engineer at Orkes, short for Orchestration. It is a weird, difficult name to pronounce, so I forgive any mispronunciations. Today we're going to be talking about scaling and managing complex agentic workflows. Lots of stuff going into this here title, but hopefully it'll be clearer what we mean by agentic workflows in particular, by the end of this presentation, and there is some non-presentation, not just slides content afterwards as well. So first, what is an AI agent? Well, what is an agent? An agent is something that can make decisions. It has agency, right? AI agents are really popular these days because AI has become all the rage. Prior to that, we had human agents, right? When somebody is looking at an application or making any kind of decision, they're an agent. You have a real estate agent or an insurance agent, right? AI agents are just taking those processes that we were already doing as humans and making it so that we can do them in an automated fashion. So what is an agentic workflow? Well, a workflow is a process, right? It's something your business does. It's something you need to do as a company. And an agentic workflow is a process that can run with agency, a process that can run on its own, right? It can make its own decisions. It might be an agentic workflow in the traditional sense with a human making the decisions, right? That's part of the workflow. It's still going to be part of that process. It decides what to do. Or in today's day and age, what we're going to be talking about largely today, it might be an AI making that decision. Could be Google's, could be Microsoft's, could be AWS, right? Wherever you are, there is an AI today that you can probably use, and you can use that within your workflows to make decisions for your business. So here we have just a little bit of a diagram. This isn't going to be a super architecture-y diagram, but it is showing you some various components of your system that are interacting with one another, both in the context of workflows, in the context of agentic workflows, but even just in the context of your business, right? So if we look at the right here, you'll notice some things that are going to be familiar to anyone who's built a large-scale system. You have some memory, right? Short-term, long-term, working memory. These are going to be things like your in-memory cache, your Redises for short-term. Your long-term might be like a long-lived business database, right? Something like a Postgres or even something a little bit more durable than that. And then working memory is likely the actual instances, the actual things you are running, your programs, right? That's your working memory. Any business process is going to have probably all three of these different kinds of memories, and those are going to extend to your artificial intelligence infused workflows as well, right? They're going to need to have a conversation. If we're talking about like a chat bot, it's going to have that working memory is for that particular chat process, right? Versus long-term memory is going to be something like the entire record of what your company has ever done so that they can contextually provide information to your users. Short-term memory and working memory in the context of a chatbot are kind of fuzzy, but point is you'll have everything here. You'll have all of these things. You'll have the core engine for actually making the decisions. You'll have the tools and systems that exist in your enterprise today to work with. And an agentic workflow is going to allow you to take all of these disparate systems and connect them to one another in a way that helps your customers without needing to have humans come in and do these expensive decision processes. So scaling agentic workflows, kind of in the title of this presentation, and something that can be very difficult, particularly for very large enterprises, larger organizations. You might notice this slide has nothing to do with AI in particular. That's because, as I've said a few times now, agents have historically been humans. And these are all largely organizational challenges, right? Complex interactions, the number of agents in an organization grow. Within an organization, within different sub-organizations, right? You have different departments at your company. They have to be able to communicate with one another effectively. They have to be able to figure out why processes aren't going the way they are supposed to. That's debugging and monitoring. Now we're taking a bunch of human-oriented problems and turning them into technical problems because we can solve those more systematically. I'm not going to read all the bullet points. Surely you've had time to by now, but these are all just examples of problems that apply to humans and apply to AI agents. And we can solve them by building these and modeling these processes out as workflows, right? So now we've talked about agents a little, we've talked about workflows a little, and what these different systems are going to look like. And so you need a base foundation to actually run these workflows on, right? What we're talking about here, and what Orkes, right, my company, kind of offers, is a runtime that can be used, a workflow runtime that can be used to run and manage these agentic workflows. Taking a step back for a second, Orkes is not purely a agentic workflow tool. It is a more abstract workflow tool. We do have agentic workflow functionality built in for a lot of these things, but that's what gives you the power to use this kind of platform and expose the same functionality to your AI agents that you might to some of your developers or to some of your human workers that you have in the loop today, right? We give you some functionality such as allowing you to have some aspects of your workflow within the development, right, within your engineer's purview, and some of it being determined at runtime. You might choose to go down one branch one way or another based on input or decisions that are made ahead of time or during execution. Additionally, we're going to allow you to, in one place, centralize what all of your agents are doing and what they can do. Governance of agents can be applied to both humans and your AI agents, right? You can use similar models of control to define what different people, or in this case, AI agents can do and can access, both from a data perspective and an action perspective, right? Things that they can do on behalf of you and your business. Model and prompt governance is going to allow you to define ahead of time what these prompts and what these agents are going to be able to do on a more like textual basis than just access and control. Like you can define the exact action that the agent can take. And that one sounds a little abstract until I get into the later portion where I'll be actually showing you some of these concepts in action, right? Role-based access model kind of plays into centralized governance agents. Auditing model responses is super useful, and again, it is useful in the scope of AI models, AI agents, because so much of what we are doing is input, output, and a workflow orchestration tool really is going to help you centralize where that input and output lives so that you can audit over time the different evolutions, the different processes that are running within your environment. Visibility into decision making, right? We talked on a previous slide about observability. You get to see where things are going, who's doing what. And finally, scaling as the workload increases. This is somewhat an AI problem, really just a system problem, right? How do you build good, scalable, distributed applications? Orkes Conductor is an example of an application where we built that in mind, right? So you're able to scale your application to meet your needs without having to worry about it on your business side. Cool. Here we just kind of run through a lot of what I was talking about previously. Task orchestration, you'll notice on the right, we have a pretty diagram. This is our workflow diagram, and you can see at various points, we are making decisions within that workflow, right? We are going down path A or B or C. This is orchestrating those various tasks, some of which might be AI related, some of which might just be boring old SQL queries to your database, right? But they're things that need to be done and decisions that need to be made with respect to one another. Not shown in this diagram, but equally as important as choosing what to do is doing things in parallel, doing things at the same time. Distributed application gives you a lot of powerful flexibility for running things in parallel, and being able to express that in your workflow is super beneficial. Error handling and recovery, very important for AI, particularly when we're talking about handling not just format of data, but also things like hallucinations, right? If you've ever gone and done prompt engineering, you're familiar with the idea of having an AI or LLM return something that is just either completely wrong or completely unrelated to what you asked for, and there needs to be some mechanism in place for detecting those things, right? So building the logic into your workflow is going to allow you to not just detect when those things happen, but detect when they happen and have, as we were talking about on the previous slide, like an audit trail of that, right? You can see historically, how often does the model hallucinate? Where are these hallucinations occurring? What form do they take, right? And having that visualizable within a context of the workflow is super, super useful. Similar monitoring and control, right? Whether it's monitoring and control of errors or monitoring and control of just a day-to-day basis of knowing what's going on, having a visual representation of the decisions that your AI agents or, again, your human agents are making is going to allow your business to operate more efficiently. And then finally, everyone's favorite, or very often least favorite topic, security, compliance, and governance is a difficult problem to solve in any context, but particularly in this budding new field of AI, where a lot of organizations don't have formal controls in place yet. So a lot of companies have the blanket statement of we're just not going to use AI because it's too hard to develop a policy around what they should have access to. By having those controls built into the tool you are using to orchestrate your workflows, you're able to get a lot of that out of the box without needing to have a very formal definition of the AI, the systems the AI can use, because they're going to be given the same like blanket of controls that your human agents have, right? Strategies for scaling. Again, not all of these are AI LLM related. First one just kind of comes along with distributed, highly scalable application. The real-time feedback and monitoring loop, this is something that you're going to want to do. I mean, this is essentially, you have a chat. I'm sure we've all opened ChatGPT. We've opened Gemini, right? We've gone and asked it questions and gotten answers and seen the thought process there as it went through. Being able to visualize that not as a chat, because it might not be a process that is ascribed to a chat format, a call and response. It might be a more long-running several responses in a row that call database systems, right? And you want to be able to see that and monitor that and potentially change your future inputs to your LLMs based on that. Humans in the loop, AI are really cool. They're fun. But sometimes you just need to bring in a real person. And by using a workflow orchestration engine like this that gives you that human in the loop capability, right? We're able to go ahead and escalate in some cases to those humans, to those people. This is particularly useful if you have some kind of approval flow. If you're an insurance company, right, and you have to go ahead and approve a claim, well, more likely than not, you will want a human to look at that eventually, but you can use an AI or LLM agent to take out the first few steps to say, hey, if there is just a very obviously incomplete application, there is a decision that needs to be made along that, and AI can reason about the first, like, hey, ask them for more information. Probably want the human to look at it eventually anyway, but the AI can get the first steps out of the way. And that's going to be a feedback loop, right? That's going to be happening multiple times, and you need some way of modeling that process. Orchestration's everywhere. I've already kind of said this a few times, right? This top little bubble here where we talk about indexing and LLM query, this is where like things like retrieval augmented generation fall under, right? Those are AI related. All of these other things around it are the things your businesses are already doing. And bringing an orchestrator in to coordinate between the things your businesses are already doing and the other things that your business wants to be doing, and the AI and ML related tools that can help you do those more efficiently is really going to be a better way of operating, right? Because you're able to go ahead and tie all of these systems together. I've talked a little bit about Conductor, which I haven't really elaborated on yet, but is what my company works on, right? Orkes, we develop Orkes Conductor. There is also an open source version of Conductor that was started at Netflix a number of years ago. We do maintain the open source version of Conductor as well as the enterprise version of Conductor. Essentially, it's a distributed decision maker, right? It's an orchestrator, it's a router, it's a state machine handler for you, right? And so you develop your workflows, you develop your applications using Orkes Conductor as the source of truth for the state of your application, and then it goes ahead and does things for you. It can do things like call APIs. You can have service workers that interact with Conductor that are owned by specific teams, by specific organizations, or even specific developers, right? You can work with humans in the loop. If Conductor is the epitome of all state, you have humans that can go in and provide input, right? They can validate output. And then finally, enforce deterministic output. As with any application, you expect some output to be how it should be, and you should be able to validate that and recover if it doesn't, right? I know not all of the people in the room are necessarily technical experts, but there are SDKs involved. So if you are going to be writing code at some point, you have your choice of SDK. For Conductor, you have Java, Go, Python, C#, JavaScript/TypeScript, and Clojure available to you for going and actually interacting with Conductor. That might be building workflows, that might be building specific tasks that you want your AI agents to be able to invoke. That might be, like I said, the workflows, and the workflows can contain invocations of AI, LLM agents, right? A lot of flexibility for you so that your teams can work cross-functionally in whatever programming languages they prefer. Agent to identify with function to call, dynamic function calling within Conductor, decision cases to pick one of these. I'll be showing this like live in a second here, so don't worry too much about this slide. Essentially, we're able to have long-running processes though, right? If agents are the ability to make decisions, we want to make decisions not just ahead of time about what our application can do, but also down the road, right? We want to make decisions on the fly as an application is running, as the process is being handled. And here on the right, again, don't worry too much about this diagram, but if you're familiar with programming, this is a loop. It is doing a certain process multiple times, and on each iteration, it is calling an LLM model, making a decision, doing some external transformation, and then waiting for human input again. So this is how you might model like a chat application, right? Something similar to ChatGPT, to go ahead and get input and then do something with that output afterwards ad infinitum, right? And at each stage, you can see what the inputs and outputs are. So you can see what chat message came in, you can see what the LLM produced, right? And this is just elaborating a little bit on that. Here we already talked a little bit about Conductor and Conductor OSS, what we offer, right? Polyglot SDKs, integrations, all of that fun stuff. It is Apache 2.0 licensed, so you can go online and fork Conductor and run it yourself if you want, if you are interested in running the open source version. We do also have Developer Edition. So what I'll be showing you in just a second here is the Orkes version of Conductor, which has several bells and whistles on top of the open source version, including some pretty tight AI LLM integration, right, to make it super easy to write prompts and to invoke your models. You can play with all of that stuff on the Developer Edition as well if you'd like. So what does that look like? Well, there we go. Here I'm going to just play with Orkes Conductor a little bit. I'm going to show you an example of building out a very simple agentic workflow. It's going to take some really silly input and make a decision based on that, right? And so we're going to go ahead and start by just defining a new workflow. This is going to allow me to basically build the shape of this process, to define what is going to happen when this process is ran. Again, we're going to do something really silly, so we're going to name this something along the lines of favorite, or let's be a bit more descriptive. Add, and it is really hard to type with one hand while holding a microphone. Add movie to favorites. Cool. So we're going to add movie to favorites, right? This is going to add a movie to a user's favorites. And so what it's going to take as input is a few things, right? Firstly, we're going to pass in some user ID. We need to know what user is favoriting this movie. We might have a movie ID as well. If we're like IMDb or some other website that has a database of all the movies we support, we're going to need to be able to reference that somehow. Next, we can start adding our tasks. We can just start saying, hey, these are the things you're going to do. A very basic example of a task that we might add is an HTTP task. Lets you call some API, right? And for this, we're just using this dummy API that doesn't really do anything. But we can go ahead and pass into this API. Maybe we pass in that movie ID to get that movie's information. If I actually ran this task, right, and we passed in the movie ID 1, 2, 3, 4, that's not going to matter much, but it will return some result. Right, so it returns this random string, and we can then use those values later in our workflow. So we can already see how we're going to take these outputs of like an API call and tie it in and provide it to an AI model down the road, right? So let's say we want to, after this API call is made, we want to ask the LLM model, tell me things about this movie. Is this a good movie? What genre is this movie in, right? If that's all stuff we have in our database, then this API call will return that information, and we can pass it into our LLM model. Now I'm going to go ahead and just go write a really quick prompt, right? We're going to add an AI prompt and Don't worry too much about the prompt engineering side of things because that is a whole complicated system and science all of its own, right? But we're going to give this a name like, was this movie good, right? And obviously, if I were an IMDb type business, I would probably have a more analytic model or a more data-oriented approach for finding out if a movie should be considered good. But if you were making other decisions based on purely logical reasoning, on historical language processing, right, then you might use an AI to make this decision. I've already added the integration with these models with Gemini, so I am using the Google Gemini models. Google Gemini 2.0 Flash is a really solid general purpose model. Description doesn't really matter, so we're just saying description. But now we can type a prompt template. So we want to find out if this movie was good. We can say very simply, a user added the movie name, and you'll notice it pops up on the right to say that we will need to provide a movie name to their favorites. Is this a good movie? Now we're going to test this model, or test this prompt with this model. What's a good movie? I think Fight Club is probably a good movie, but let's see what it responds with. That's a lot of data. Now, in reality, if you were building an agentic workflow, you would probably specify a JSON schema and say return a valid value that conforms to this JSON schema, and then you could parse that and use that in your actual workflow as like data, and thus use that to make decisions. But for now, I'm fine with this output. We're going to save this and confirm this. And if we go back to our workflow definition and select our LLM, we have the was this movie good prompt, and we can provide a value to movie name. Now, I showed you earlier, I made an API call before. If I wanted to use some part of the output of that API call, I could do so, right? In this case, that API call doesn't contain anything that is a real movie name. So we're just going to put a hard-coded value here for now, Happy Feet, right? We want to know if Happy Feet was a good movie. And let's make another API call to that same endpoint. But this time, we're going to use the output of our LLM prompt. So we'll take this output.result. And if you notice, this takes in the movie ID, doesn't really matter what that is. This has some input for Happy Feet, and this has some input for this bogus value, which again, doesn't really matter at the moment, but that's okay. If we save this workflow, and now we go ahead and actually run it, we can provide dummy values for movie ID and user ID, which will not actually matter. But when we run the workflow and we call our LLM model, we can go ahead and see the input that this took. And so hopefully you can actually, let me zoom in a little. So now hopefully you can see that for our prompt variables, we passed in movie name, which again, I hard-coded Happy Feet, but would more likely than not be the result of a database call or some other API call, right? And if we go ahead and refresh this, now that it's finished with that inference, we can go to the output of this task and see this entire result here. Again, whether or not Happy Feet is a good movie is subjective and depends on individual taste. But then our next API call is taking that same big response and using it as input. So whatever your AI does, whatever your LLM does, I'm not going to teach you how prompt engineering works. That's, again, huge conversation that needs to be had. But you can already see we're able to pass inputs around. We're able to produce outputs for these workflows. And depending on if you had decision-making in your workflow or looping in your workflow, these could very easily represent long-running processes that are capable of acting on their own or making key business decisions for you along the way, right? The extent to which you want to do so is going to matter very largely on your business. But you can see already that being able to automate these processes is a super powerful ability. I think that aligns me up to about 30 minutes. So I am happy to take Q&As or... Yeah. So if there are any questions from people in person or online, yes, sir.
Great. So this is super cool and great demo. Thank you for explaining it so well, so quickly. So my wonderment is, do you have any kind of chat-like interface to make it easy to describe the kinds of workflows you're doing? And then the second question is, since I tend to do everything in code, is there a way to just do this via code?
Yes, wonderful questions, both of those. So I'm gonna actually answer them in reverse order, if that's okay with you. So firstly, let me go to my workflow definition. This is the workflow definition editor. It is a visual editor that we offer. At the end of the day, the workflow is a JSON document. It's a JSON DSL, right? This is actually an open format. So I guess I'm kind of answering your questions at the same time. This is an open format. This is the same format between the enterprise version of Conductor and the open source version of Conductor. So if you go to the open source version of Conductor, we've got several examples for workflows in JSON. Well, the open source version of Conductor has been around for years and years and years. So if you go to Gemini or ChatGPT, you can actually ask it to write a Conductor workflow to do certain things. Now, that's actually not why I have ChatGPT open. I guess I could ask it to if you want. But in addition to that, we are currently working on a product to allow you to have a more tailored Conductor-specific ChatGPT-esque offering that will also allow you to do things like define database connections and other infrastructural connections, because this format for the workflow itself, well, that's an open format and very well understood by ChatGPT. Things like, how do I define a JDBC query that can be formatted specifically into the API call that I need for Conductor to connect it to my workflow, right? Those are a little bit more obscure. So we are going to offer that fairly soon. The other question you asked was related to defining workflows via code. Yeah, most, not all of our SDKs, most of our SDKs do support workflow as code as well. So if you wanted to write your workflow using Java, you want to like build a Pojo, you totally can. Go, C# also do. Python, I don't think JavaScript does support it, but it's out there, right? Yeah.
Thank you. So my question is more about the business use cases. So it's up to whatever you want it to do. But so far, do you have any specific workflows or use cases that people have a lot of interest in using or implementing?
Yeah, absolutely. So I'm going to take a step back from the AI lens for a second, because AI is still relatively new and people are still experimenting with it. Conductor itself was started by Netflix in the early 2010s as part of their move from like on-premises data centers to the cloud before there was a good like workflow tool in the cloud, right? And so Netflix originally made it to handle all of their business processes, from login to ad serving to determining what title to show you, right? Those were all various parts of processes that were handled by Conductor. That was how it started. In today's day and age, it handles basically any kind of process where you want things like failure handling, observability. I can give some very fun examples. I think my favorite example, my favorite example is a medical device. I don't remember if it's a CAT scan or an MRI machine, but there's a medical device where they run the open source version of Conductor locally on the device to run the processes to actually do those medical scans. We have NPR uses us for like doing various parts of their pipeline for video, audio transcoding, right? There are a lot of other media ones. I'm not exactly sure who is publicly referenceable. Maybe, let's see. We have shipping logistics customers, insurance customers, finance customers who use us for handling application processes and pipelines, right? Some functionality that you might expect from a like business tool. So things like defining a cron job to go ahead and run a process at some periodic interval, right? That's a very popular thing that businesses need to do. And a lot of businesses will do them, particularly old guard businesses. Some people have actual like PowerShell scripts running on an individual laptop in a conference room somewhere that does this every 24 hours. So being able to centralize that kind of thing, right? Let's see. Is there a particular business use case that's interesting to you? Yeah, it's a very general purpose platform. If we want to talk a little bit about like the goal of Conductor and the goal of Orkes, or some goals anyway, a lot of the ideas is this is the way you should build systems and applications, right? You shouldn't need to worry about spinning up a Kubernetes cluster yourself and a database yourself just to do very simple state management. You probably still will need to spin up a Kubernetes cluster or a database for the foreseeable future at some point for your business. But for your day-to-day activities and for managing processes, that's totally overkill for most business units, right?
Few question. I was just trying to logically connect the Jenkins pipeline to the conductor agentic workflow. So what if something fails in between, right? So how can you remediate that, like, and in a maintenance fashion, like, life cycle management?
Yeah, several different ways of doing so. And I'm going to tell you, firstly, I think the easiest and most widely used, right? If we go to our workflow here, and I'm going to zoom out again a little because it's kind of overwhelming. Let's say this workflow fails. We want to handle that failure in some way, right? Actually, before we even get into that, let me go ahead and make it so that this API call fails. We're going to make this call to .comma, and because that's not a valid domain, when we run this workflow, it's going to try to make that API call. It's going to fail. This workflow is going to fail. Nothing worked, right? If we go back to the definition, there's a very handy setting called the failure workflow. This is very similar to a try-catch, right? It's if this thing fails, do something else. And so in this case, maybe we want to call the alert workflow. And so now when I call this workflow and I go ahead and actually click run, right? This workflow is still going to fail. I didn't fix anything. It's still going to make an API call to something that doesn't exist. But now you'll notice in the top, there's a little bubble that says triggered failure workflow, right? And if I go over to where that is, it's a pretty boring workflow. It doesn't actually do anything, but we could do whatever we wanted here, right? We could trigger a Slack notification or a PagerDuty notification, or this workflow that we've triggered as part of our failure actually gets the entire state of the workflow that failed as input. So we can actually go ahead and make decisions within our failure workflow about the other workflow that actually failed. We could undo things that it already did. We could go ahead and make reasoning and logical decisions. And that's something you could even involve an AI or LLM to do, right? Yeah, and there are a lot more niche ways of handling failures as well, but that's probably the most general purpose.
Hey, congrats. Looks like a pretty cool app and project. I was curious. I usually use Zapier to do similar stuff, just connecting it to ChatGPT to OpenAI or to Gemini, and I can create workflows that way. I feel like that's more like a no-code solution, and I'm just curious, is this like kind of a similar type of idea, but more focused into developers?
That's a very nice way of like kind of summarizing it towards the end there. We try very hard not to market ourselves as a no-code or a low-code tool. We do have customers who are using us, who have like certain business users who are using Orkes Conductor and logging in and making very simple workflows. But day to day, the general people that we're targeting are developers, are engineers. I didn't really show much of building individual tasks or like writing code that interfaces with Conductor much, but for the most part, these workflows that you're going to be defining are going to be made up of these tasks. And these tasks largely will contain your business logic. These will contain your code. And these are things that you will need engineers or developers to come in at some point and say what's going to happen, right? Now, there are aspects of this that you can hand off to business users. In particular, right, if we had a human in the loop task, which goes ahead and shows a form to someone, that form could likely be filled out by someone who has no like lick of computer literacy, right? But the workflow definitions, the individual tasks will very largely be used by engineers, by developers. Conductor is kind of first and foremost a microservice orchestration tool, right? And that's how I tout it to a lot of people when I'm talking to people who are more engineering oriented. When we're talking about workflows, like you said, a lot of people think of Zapier, or there are a couple of others that are more business oriented, right? That are meant for people to do very, very quick and dirty automations. But yeah, it's an engineering tool primarily.
Right. Okay, and let's take a couple more questions. So is there a general use case for this for iterating on code? just like if you want to write a small script, I will generate small scripts on the first try a lot of the time using ChatGPT, but sometimes I do kind of iterating just to like, fix out some bugs or improve it a little bit. And sometimes I'd like to just kind of let it iterate automatically, check did it compile or not. Have you done anything like that with this?
So that's definitely part of what, I don't know if the project name we have for it is public yet, but the tool that I was mentioning earlier that we have that's doing like agentic workflows, and that is particularly creating agentic workflows agentically, right? In which you can kind of conversationally create the workflows that you want. That is taking largely a more iterative approach, right? When it comes to building workflows manually, like in our UI here today, like you kind of saw me clicking through and doing, there is not currently, and I don't think we have a plan to bring like AI and LLM into that experience in particular, largely because a lot of our customers do have a lot of like data privacy concerns. And so bringing it in as like a blanket feature for the product, we're not quite there yet, but it will be a part of the agentic focused product.
Any other questions before we wrap up? Going once, going twice. Okay.
Cool.
Thanks, Haven.